Deep inside this concrete tower lies an industrial apex predator, the SSI Quad-Shear Q100 Heavy Duty. 25,000 pounds of steel muscle, generating 80,000 pounds of kinetic cutting force. Today it will consume an entire enterprise data center in just 8 hours. Inside these racks, $2 million of hidden gold, solid copper, and precious earth metals waiting to be violently liberated. Every single second, human civilization generates terabytes of digital history. All of that history lives on physical servers. But when the cloud reaches the end of its lifespan, it doesn't just disappear. It comes here to Sims Lifecycle Services in Jersey City. This 5-story urban processing fortress is specifically engineered for one singular purpose: total, absolute, and highly profitable destruction. Watch the first point of impact. The Q100 doesn't just crush, it shears. Those rotating blades are forged from Hardox 600 manganese steel, boasting a Brunel hardness rating that makes aerospace-grade aluminum behave like wet cardboard. As the primary rotor grips the outer chassis of the server rack, 45,000 pounds per square inch of tensile strength instantly surrenders to the machine's torque. The acoustic shockwave of shattering cold-rolled steel registers at 112 decibels. But the real prize isn't the steel shell. It is what is buried deep inside the silicon architecture. These high-density blade servers are packed with premium recoverable commodities. Look closely as the teeth bite into the motherboards. That explosion of green fiberglass and white dust is exposing the high-value payload. Solid copper heat sinks, designed to keep overclocked processors cool, are sheared in half in a fraction of a second. At current market pricing, that copper represents thousands of dollars per ton. Even more lucrative are the microscopic layers of wealth hidden in the connectors. Every single RAM slot, every CPU socket, and every PCI bridge is plated with pure 24-karat gold. The Q100's blades are deliberately calibrated to tier these components into precise, uniform fractions, breaking the mechanical bonds between the plastic, the copper, and the precious metals without pulverizing them into unrecoverable dust. Listen to the audio profile shifting. That dense, resonant cracking sound is the destruction of enterprise-grade hard drives. The blades are tearing through heavy aluminum housings and shattering the glass-infused magnetic platters inside, unleashing distinct showers of white-hot sparks that burn at nearly 3,000 degrees Kelvin. Operating at a massive 400 horsepower, the dual electric motors draw an immense surge of current to maintain a relentless 35 revolutions per minute. There is no jamming. The shredder simply demands more power, maintaining the crushing force necessary to digest over 15 tons of raw e-waste every single hour. In a standard 8-hour shift, this single machine will process enough data center infrastructure to stretch across 3 football fields. As the fragmented remains cascade through the discharge screen, the chaotic tangle of modern computing has been fundamentally reset. What was once a highly organized matrix of digital information is now a raw, flowing stream of highly valuable commodities. This is the first critical phase of the recovery cycle. From here, this multi-million-dollar river of shredded tech will move deeper into the massive facility, where advanced physics, optical sensors, and magnetic separation will extract the pure, unadulterated profit. This isn't just a machine. It is the beating heart of a sprawling, multi-acre industrial fortress perfectly engineered to reverse-engineer human progress. Welcome to the macro scale of global commodity recovery. From a static hover at 500 feet, the true magnitude of this Jersey City operation becomes undeniable. You are looking at 50,000 tons of processed inventory spread across dedicated, specialized zones. What looks like a chaotic concrete labyrinth is actually a highly orchestrated supply chain, generating tens of millions of dollars in annual revenue. Every single truck that crawls over those commercial scales is carrying up to 40,000 pounds of obsolete digital infrastructure. And the facility devours it all, non-stop, feeding a logistical beast that simply never sleeps. Watch the heavy equipment swarm. The massive Caterpillar loaders and Cenobogan material handlers are the arteries of this operation, moving mountains of value with terrifying ease. That towering pile of silver isn't trash. It is 200 tons of pure, shredded aerospace-grade aluminum, currently commanding nearly $2,000 per ton on the global market. Adjacent to it, separated by thick concrete retaining walls, sits the high-value payload, an intense, glowing mountain of shredded copper. In an industry where profit margins are razor-thin, the absolute efficiency of separation is the only thing that matters. The genius of this operation lies in the seamless integration of raw, brute force and hyper-advanced physics. Once the Q100 shredder violently reduces the data centers to uniform 2-inch fragments, the real magic begins inside those elevated conveyor towers. The material is subjected to immense 10,000 Gauss electromagnetic drums, ripping the ferrous steel vertically out of the debris stream. What remains is fired at high speed through optical sorting lines, where near-infrared sensors scan thousands of fragments per second, triggering pinpoint pneumatic blasts to separate the aluminum from the precious metal-bearing circuit boards. The resulting purity is staggering. The final product isn't a mixed pile of garbage. It is pure, dense, raw material ready for the smelter. Look at the Mezzo-Lindemann balers engaging. 300 tons of hydraulic pressure violently crushes loose copper into impossibly dense, 4,000-pound cubes. These cubes are loaded directly into reinforced steel shipping containers, secured, and driven straight out the automated gates in heavily armored transports. The geographic location of this facility is no accident. Flanked by massive rail lines and the deep water ports of Newark Bay, this operation has direct, unhindered access to the global commodities market. But a facility of this scale requires an insatiable amount of energy. The electrical substations alone house massive industrial transformers processing the megawatts necessary to keep the dual 400 horsepower motors of the Q100 from stalling under load. The hydraulic systems run so hot that massive, closed-circuit Evapco cooling towers must constantly circulate hundreds of gallons of water per minute just to prevent catastrophic meltdowns. Every single moving part, from the ballistic glass sorting cabins to the digital Vulcan scrapware tracking the weight of incoming trucks, is monitored live by a central SCADA control room. The physical footprint of the digital age is massive, and it takes an even more massive machine to process it all. Speed and scale. Two metrics that define absolute industrial dominance. Processing a $2 million data center requires more than raw power. It demands unparalleled versatility. From microscopic silicon chips to massive cold-rolled steel server racks, the machine must consume, adapt, and obliterate everything in its path without hesitation. This is the absolute apex of mechanical digestion. The true measure of a world-class shredding facility is not just how hard it can bite, but how fast it can swallow. The SSI Quad-Shear Q100 Heavy Duty is an omnivorous predator, engineered to transition seamlessly between entirely different classes of electronic waste. In a single continuous shift, the feed hopper receives a chaotic, unpredictable diet. 1 minute, it is digesting thousands of obsolete solid-state drives, fragile fiberglass RAM sticks, and brittle smartphones, snapping the thin silicon and dense lithium-ion cells at a blistering rate of 50 units per second. The next minute, a 2,000-pound monolithic telecommunications network switch drops directly from the Cenobogan grapple claw, demanding a massive, instantaneous surge in rotational torque to effectively shatter its incredibly thick aerospace-grade aluminum chassis. The machine does not stop to adjust. It does not hesitate. It simply demands more raw electrical power from the local grid and pushes relentlessly forward. This engineered versatility is the absolute foundation of the facility's financial model. At an operational overhead cost of thousands of dollars per hour, any mechanical downtime or jamming is absolutely catastrophic to the daily bottom line. The dual 400 horsepower electric motors maintain a brutally steady 35 revolutions per minute, utilizing a highly advanced, responsive hydraulic drive system that automatically senses material resistance. When the Hardox 600 blades encounter a highly dense, extremely resistant cluster of solid copper server power supplies, the machine instantly shifts its internal hydraulic pressure, temporarily trading rotational speed for pure, unadulterated, unstoppable crushing force. Watch the precise cycle times as the materials change. A standard aluminum desktop computer tower is violently reduced to unrecognizable 2-inch fragments in exactly 1.4 seconds. A heavy 50-pound uninterrupted power supply, packed completely tight with dense lead-acid battery cells, takes precisely 3.2 seconds to process. But when a fully loaded 42-unit enterprise server rack directly hits the counter-rotating teeth, the destruction becomes a sustained, agonizing, and highly visual event. The primary 11-gauge cold-rolled steel frame desperately fights back, warping, buckling, and screaming under the 80,000 pounds of localized cutting force. Yet, within a mere 8 seconds, the entire massive structure is pulled inexorably downward into the dark, churning abyss. This multi-material simultaneous processing creates a terrifying, chaotic symphony of total destruction. The massive blades are simultaneously shearing highly ductile copper heat sinks, shattering brittle glass-infused data platters, ripping incredibly elastic rubber power cables, and folding rigid steel structural beams. Each distinct material fails completely according to its own unique metallurgical properties. The highly skilled operators sitting safely inside the climate-controlled control room monitor these exact efficiency metrics in real time, tracking the processing speed versus the global market value recovery. The ultimate goal is absolute, unyielding volume, reducing every single piece of complex technology into an identical, uniform commodity fraction ready for separation. Some materials are forged to be indestructible. They are engineered to withstand ballistic impacts, absolute thermal shock, and the crushing weight of time itself. But inside this concrete fortress, indestructibility is simply an engineering challenge waiting to be solved. When the machine meets military-grade armor, solid forged steel, and aerospace titanium, it doesn't stop. It just gets violent. Welcome to the absolute limit of mechanical destruction. You are looking at an SSI Quad-Shear Q100 operating at 110% of its rated capacity. The manual override protocols have been engaged. The safety limiters are completely off. The machine is currently biting into an AR-500 armor-plated, military-grade data vault. This steel has a tensile strength exceeding 200,000 pounds per square inch. At first contact, the massive Hardox 600 blades actually fail to penetrate, violently dragging across the armor and generating a blinding, localized storm of 3,000-degree thermal friction sparks. But the dual 400 horsepower motors refuse to stall. They draw maximum amperage from the grid, forcing the incredibly dense steel to yield, completely shattering the hermetic seals and tearing the vault wide open. But the true challenge lies hidden inside. The internal server frame of this vault is forged entirely from solid T6Al4V aerospace-grade titanium. Titanium is notoriously difficult to process because it possesses incredible elasticity. It bends and fights back against the shear. As the teeth grab the massive titanium pillars, the entire 25,000-pound machine visibly shudders. The extreme physical tension builds until the titanium catastrophically fails, snapping with an explosive kinetic shockwave that generates a completely distinct, brilliant white 4,000-degree spark shower. It is a terrifying display of absolute metallurgical failure. The machine's sheer versatility is heavily tested when it encounters a 4,000-pound industrial kinetic energy flywheel. This solid forged carbon steel cylinder boasts a flawless, curved geometry that denies the blades an easy bite. The machine stalls. The highly advanced Allen Bradley PLC control system instantly triggers the auto-reverse protocol, violently ejecting the block upward before aggressively attacking it from a completely new angle. The blades gouge a massive trench into the smooth steel, finally violently splitting the 2-ton block entirely in half with an earth-shattering boom that physically vibrates the entire 5-story processing tower. Even materials engineered for extreme thermal environments, like Inconel superalloy exhaust manifolds, are fundamentally unmade here. The incredibly tough nickel-chromium alloy refuses to snap, forcing the machine to brutally tear it apart. The immense kinetic friction causes the thick metal to literally glow a menacing cherry red at the exact shear point before finally tearing with sluggish, agonizing resistance. Regardless of the material's original density, hardness, or engineering pedigree, the absolute final result is always exactly the same. The massive 2-inch heavy steel sizing grate beneath the cutting chamber ensures perfect uniformity. The incredibly dense, highly jagged fragments of titanium, forged steel, and Inconel are violently pounded against the screen, violently swept backward, and recrushed until they perfectly match the required size. As this incredibly heavy, deeply dark river of extreme commodities flows onto the primary output conveyor belt, the brute force phase is entirely complete. The machine has successfully stripped the absolute hardest materials on Earth of their identity, perfectly preparing them for the highly advanced, incredibly profitable separation phase. The sheer violence of the primary shredder is only the prologue. True financial dominance in the recycling industry isn't achieved through brute force alone. It is achieved through absolute, uncompromising purity. Once the Q100 reduces the data center to millions of identical 2-inch fragments, the chaotic river of scrap must be untangled. This is where mechanical destruction ends, and highly advanced, multi-million-dollar physics begins. The mixed material is rapidly conveyed into the separation towers, where it encounters the first line of defense, the 10,000 Gauss electromagnetic drum. This massive, invisible field violently rips the heavy ferrous steel vertically out of the stream, defying gravity to isolate the iron contact. What remains on the belt is a highly concentrated, non-ferrous payload of aluminum, copper, and precious metal-bearing circuit boards. But sorting non-magnetic metals requires a different kind of physics. The material is fed over a high-speed vibratory table, shaking the fragments into a perfect, single layer before they drop off the edge of an eddy current separator. Beneath the belt, a titanium rotor spins at 3,000 revolutions per minute, generating a rapidly alternating magnetic field. This field induces electrical currents within the highly conductive copper and aluminum, creating a massive opposing magnetic force. In a beautiful display of physics, the heavy metals physically leap forward through the air in a perfect parabolic arc, while the inert, worthless plastics drop straight down into the waste bin. Yet, copper and aluminum must still be separated from each other. The stream is fired through a TAMRA optical sorting line. Near-infrared lasers scan the elemental composition of every single flying fragment in a fraction of a millisecond. An artificial intelligence system instantly maps the targets, triggering an array of 400 microscopic pneumatic nozzles. Pinpoint blasts of compressed air aggressively shoot the silver aluminum down into a chute, allowing the heavier, bright orange copper chops to fly untouched into the premium collection bin, achieving a staggering 99.9% purity. The highest value materials, the green server motherboards, are routed to specialized optical color sorters and precision granulators. The fiberglass is pulverized into dust, cleanly freeing the microscopic 24-karat gold pins and palladium capacitors. These precious fragments are chemically leached and dropped into a titanium crucible. At 1064 degrees Celsius, the fragments collapse into a blindingly radiant pool of molten liquid gold. Poured into a graphite mold, cooled, and stamped with the facility's hallmark, the data center's hidden wealth is finally consolidated into a singular, undeniable physical asset. Loaded into secure Pelican cases and guarded by heavily armed transport teams, these gold ingots, along with thousands of pounds of pure copper and aluminum bales, are shipped back into the global manufacturing supply chain. In just 8 hours, a massive data center has been completely erased, yielding millions in pure profit. Behind the deafening noise, the blinding sparks, and the towering mountains of shredded steel lies the true engine of this entire operation: global high finance. This 2,600-acre concrete labyrinth is not a graveyard for dead technology. It is a highly aggressive, meticulously calculated commodity manufacturing plant. Every single rotation of those massive manganese steel blades is intimately tied to the real-time fluctuations of the London Metal Exchange and the COMEX. When the global demand for copper spikes, the Q100 shredder runs hotter, faster, and longer. The financial life cycle of destruction begins the exact moment a heavily loaded semi-truck hits the inbound commercial scale. Using advanced Vulcan scrapware software, operators log the exact gross weight while expert inspectors on the yard utilize handheld X-ray fluorescence analyzers to instantly determine the precise metallurgical breakdown of the inbound material right down to the atomic level. There is zero guesswork. Before a single obsolete server rack is even dropped into the primary hopper, the facility already knows exactly how much pure aluminum, heavily shielded copper, and 24-karat gold it contains, and exactly what that specific payload is worth on the open market. The margins in this industry are won and lost in the absolute fractions of a percent. The scale of the outbound logistics is equally staggering. Those massive 100-ton gondola rail cars aren't just hauling scrap. They are transporting premium heavy melting steel directly to massive domestic mills, where it will be melted down and forged into the structural I-beams that build our modern cities. Those fully loaded 40-foot shipping containers leaving the fortified gates are carrying millions of dollars in highly compacted, 99.9% pure copper and aerospace aluminum wire chops. Escorted by heavily armed Brinks transport teams, these high-value materials are destined for massive deep-water ports and international refineries, fed right back into the global manufacturing supply chain. As the sun sets over the distant Manhattan skyline, casting incredibly long dramatic shadows across the endless piles of processed wealth, the true legacy of this facility becomes undeniably clear. Decades ago, metal recycling was a grueling, dangerous manual process, entirely reliant on small mechanical alligator shears and intensive human labor. Today, it is a fully automated, artificially intelligent, multi-million-dollar apex predator of an industry providing highly skilled jobs to the community. The generational evolution from a dusty, chaotic scrapyard to a highly secure, data-driven commodity extraction fortress is a profound testament to human engineering. We live in an era of unprecedented, incredibly rapid digital consumption. Every single day, humanity discards thousands of tons of obsolete blade servers, shattered smartphones, and outdated telecommunications infrastructure. Left unchecked, the physical footprint of our modern digital lives would completely bury us. But inside this towering concrete fortress, obsolescence is violently and permanently cancelled. The machine does not care about the data you lost, or the incredibly complex engineering of the titanium data vaults it crushes. By subjecting our discarded technological history to unimaginable kinetic violence, this facility ensures that the fundamental building blocks of our future are never truly lost, but perfectly, profitably reborn.